So welcome back to another session. We are going to look at practice 3, 4 and 5 of the class handout GN functional group nomenclature. I'm not going to solve all the questions because you have been given an answer key in class. You can check your answers from that. I'm just going to go over a few important ones or the ones that I feel like maybe look complicated. So before we start, let's quickly review the rules for naming functional groups. You look for the highest priority functional group. And just like we did in class, you try to memorize the order of the functional groups. It's easy if you break it down as acid, ester, amide, aldehyde, ketone, alcohol, thiol, amine. And then everything else after that simply follows the first point of difference and alpha order. Having figured out your longest functional group, you look for the longest carbon chain that contains your functional group. If possible, you include the other groups in your chain. If it's not possible, then those groups go by their prefixes. You then look for the first point of difference for all the other groups and you write the name in an alphanumeric order, which means even if the number for say ethyl group is 4 and the number location for the methyl group is 2, you will write 4 ethyl, 2 methyl, simply because E comes before M. Let's take up some examples. So let's look at question number 4. We've got two different aldehyde groups on this molecule. Aldehyde is more important than the methyl substituent. So the aldehyde gets the lowest number. We start numbering at 1 and the other aldehyde group gets the number 5. This tells me that this is a pentane dial. We can write 1,5-dial, but we don't have to because the aldehydes are always a terminal group. So they have to be at the ends of the chain. Then since in both cases, whether you number from left to right or right to left, the aldehyde gets the numbering 1, 5, then let's try to see if it is possible to give lower numbers to the methyl groups. So let's pick the first point of difference and give 2, 3 as the location for our methyl groups. Then the name becomes 2,3-dimethyl pentane dial. Notice the E. If it was a single aldehyde group, the name would be pentanal. Let's look at number 7. Let's identify the functional group present. This is an ester and here is an ether. Ester is more important than the ether. You also have to recognize that this is a benzoate coming from benzoic acid. So the end of the name is benzoate. Ethers are named as alkoxy. So this is a methoxy substituent on an ester. And this is the alkyl group. The part that is attached to the oxygen is the alkyl group. What kind of alkyl group? The numbering starts at the carbon that is attached to the oxygen. So then this is a 3-methoxy butyl benzoate. So between the methoxy and the butyl, you don't leave any space, but the methyl and the benzoate, you do leave space. For esters and acids, we will leave a space. Another example, let's say number 11. So you have to recognize that this is an amide. The name of an amide is N-alkyl, N-alkyl, alkanamide. The alkanamide part of the name comes from the chain that has the carbonyl group. This CO is the carbonyl group. So this becomes the alkanamide. Let's count the number of carbon atoms in this chain. Let's look at the other substituents present. So you have a methyl here, an ethyl here, M, M, M. Ethyl comes before methyl because E comes before N. So the name becomes N-ethyl, N,3-dimethyl hexanamide. I just want to take up number 15 because I think that was wrong in the answer key. Just make sure you identify the functional groups generally. So this is a ketone, ketone. So this is some kind of a dione. So let's look at number 5. This is a tertiary amine. You've got methyl, methyl. You've got another methyl substituent, and then you've got chlorine as substituents. The names of amines are N-alkyl, N-alkyl, alkanamine. The alkanamine comes from the longest carbon chain. Let's try to give the smallest number to the amine group because amine is more important than chlorine. So 1, 2, 3, 4, 5, 6, 7. So this is a heptanamine, and because C comes before M, we will write the chloro part first. So 7, 7, 7 trichloro NN24 tetramethyl heptanamine. Let's look at practice 4, part G possibly. So identify your various functional groups present here. There is a double bond. This is an ether, ethoxy, and a chlorine. So double bond is the most important. The others are in alpha order. Let's try to use the first point of difference for the others. So if you want to give 1 to the double bond, again, the most common mistake is that kids can sometimes make the double bond between carbon 1 and carbon 6. So they go numbering this way. Please try not to do that. The double bond is always with adjacent carbon atoms. So it's between 1 and 2, 2 and 3, 4 and 5, and so on. So if we go numbering here, 1, 2, 3, 4, we get 1 for the double bond, 2 for the ethoxy group, and 4 for chlorine. But what if we started the numbering here? 1, 2, 3, 4, 5. So you would get 1, 1, 5. So you're still getting 1 for the double bond in both cases. So now you're looking at the first point of difference for the other groups. And since in the green numbering, the ethoxy group gets a lower number, we will choose the green numbering. And in writing, we will write the chloro first. So we will say 4 chloro, 1 ethoxy. Sorry, the green numbering has 5, my bad. 5 chloro, 1 ethoxy, cyclohexene. Let's look at another example, Q. So we identify the groups present. So this is a ketone, chlorine, chlorine. Ketone is more important than the chlorine. So the lowest number goes to, oh, I forgot the double bond here. The lowest number goes to ketone, 2, 3. So our name becomes 2,3-dichloro cyclohex 2N1-one, or you could write the same thing as it is, 2,3-dichloro cyclohex 2-enone. That is also acceptable. What else seems okay? Let's look at T. So let's first identify the functional groups present here. So there is a double bond, there is an aldehyde, there is an ether. Aldehyde is the most important, double bond is second, and ether is third. So let's try to give the lowest number to the aldehyde. Then let's find the longest carbon chain that contains the aldehyde, and if possible the double bond. Yes, it is possible. 6. Now we've got a choice. Do we go to the right or do we go to the left? If I go to the right, I get 7, 8 carbon chain. If I go to the left, I also get the 7, 8 carbon chain. But I'm better off picking left because this gives me less complicated substituents. Okay. So let's look for what substituents are present. So there is a methyl group, starts with an M. An ethyl group starts with an E. This would become ethoxy, so starts with another E, and there is another methyl group. So let's name this compound. So the name becomes 2-ethoxy, 6-ethyl, and then 3,7-dimethyl. Either we can say 4N-octenal or oct-4N-al. We don't need to say 4N1-al, but I will not take away marks if you did. But there is something else you should pay attention to. There is a double bond here. You are given a line diagram, which means you are told if this molecule is cis or trans. So you should write that before the name starts. So let's say cis 2-ethoxy 6-ethyl 3,7-dimethyl oct-4-enal. Even here, there is a double bond. You're given a line diagram, so you can tell that this is actually trans. Whatever else the name of the molecule is, there is an ether present, starting with an M. There is a hydroxy group. There is a chlorine. You can look for the longest carbon chain and the first point of difference, trying to give the lowest number to the hydroxy group. Practice 5. Let me pick ones that look interesting. Let's look at E. Let's find the functional groups present here. So the first thing I notice is there is an ester, chlorine, chlorine, chlorine. So esters are named as alkyl alkanoates. where the alkyl part of the name comes from the carbon chain that is attached to the oxygen. So this will become your alkyl, and the carbon that contains the carbonyl carbon becomes the alkanoate part of the name. So we'll start the numbering here. 1, 2, 3, 4, 5. So this is a pentanoate, 4,5-dichloropentanoate. And the alkyl part of the name, the numbering starts at the carbon that is attached to the oxygen. So 1, 2, 3, that's the longest carbon chain. So 2-chloro, 1-methyl, propyl. So remember, we said that you will leave some space between the alkyl and the alkanoate. So we're going to name it like this: 2-chloro, 1-methyl-propyl, 4,5-dichloropentanoate. Let's look at S. So S has got 3 amino groups. This means this is some kind of a triamine. Then it's got all these chlorines attached to it. Amine has higher priority than chlorine. So let's give a lower number to the amine chain. 1, 2, 3, 4, 5, 6, 7. So then the name becomes 6, 7, 7, 7. Tetrachloroheptane, write the E, and 1, 1, 5 triamine. Let's look at U. The easiest thing here is to miss the amide group. Here's an amide. This is an ether, another ether, amine, hydroxy, alcohol. So let's decide our order of priority. Amide is the most important, alcohol is second, amine is third, and then the ethers have the last priority. But really it doesn't matter. Once we have decided that the amide is the most important group, we are only going to use first point of difference and nothing else. So let's get started. The amide part of the name, alkanamide, comes from the carbon that contains the carbonyl carbon. This is a heptanamide. Now let's write our order for naming. So in the alpha order, you've got amine starts with an A, alcohol starts with H, hydroxy. So A comes first, H comes second, methoxy comes 3, and methyl comes 4. So then the name will become, where do we have the amino group? At 4th carbon, 4-amino, 5-hydroxy, N2-dimethoxy, N6-dimethylheptanamide. I think I'm going to pause here. That's plenty of examples for you. I hope you've been doing the practice all along. Good luck for your test.